Welcome to another work in progress video. This time I'm going to show off some of the hierarchy trees that I've got. Hierarchy trees are complex objects. You will have seen these trees before. These are the original ones, and they're fairly simple shapes. They're just a couple of polygons crossed over, and they look alright. They do the trick for most things, and they're very popular in R-Factor games. What I've been working on is something a little bit more complicated, and that will allow you to create more complex trees, and it will generate things that look substantially different to each other. At the moment, the branches, the trees have randomness to them, and so you can get all sorts of different shapes. If you don't like one, you can just create another one. Obviously these are taking up a lot more polygons than the simpler trees, and there's a few things I've built into BTB that will help with that when you're trying to display them in the game. You'll notice here that the objects are made up of several different objects, all in the usual sort of hierarchy. You have a trunk, you have branches, main branches leading off that, you have smaller branches leading off that. Then you have the leaves themselves. All of this can be arranged and edited within the Xpacker utility. Just quickly I'll show you the XML file that goes along with it. Actually, if I show you the directory, you can see there's all the files relating to tree 5 and all the XML files. Now, you don't have to worry too much about the details, but just to show you how things are kind of arranged, we'll look at the main tree file here. Contains two objects. It contains the main trunk, and it contains a level of detail object. This is an object that has far less polygons, and it's used for when you're in R-Factor and you're a long way from the trees. There's no point rendering all of the detail in that tree because you just can't see it. So when you're far away, a much simpler version of the tree is rendered for you, and that just speeds up the rendering, the in-game frame rate when you've got lots of these trees. The other thing that we have in there, if we look at the trunk file now, which is this one here, scroll to the top, you'll find that the first object there is a shadow. Again, if you were to calculate shadows using every polygon in this object, it would be very time consuming for very little gain. So behind the scenes in the XML, we've got this shadow object, which is again a cut down version of the tree, which is used just for shadow calculations. Also, collisions are done a little bit differently. A collision object is created for the tree instead of using the whole tree for detecting if a collision is made. That means you'll be able to drive through the smaller branches and the leaves without being affected. You won't be able to drive through the trunk. But again, using a separate object for the collision detection saves you from having to test all of these polygons in R-Factor, which is a big saving if you've got hundreds and hundreds of trees. So getting back to the XML, you can see that the trunk here has one shadow object, which is always created, and then a number of these branches, all being the same branch, just at different scales, different positions, different rotations, and with randomness applied. Each of them has a percentage that they might get born. This one has a 30% chance of being added to any given tree, and it all adds up to good variety in game. The tree designers are going to have a little bit more work for them cut out, as there's a lot more in here than the regular trees, but you can do pretty much all of it through Xpacker, the arranging of the pieces, so that really helps, and hopefully we'll get some really good looking trees in games. Just to show an example of, I've kind of gone to the extremes here and added quite a few trees in here. You probably wouldn't want to do as many as I have here, but we'll just trip around and show you some of these trees. You'll notice off in the distance I've still got some fine tuning to do. The popping up effect still occurs where you're transitioning from a low detail to a high detail object. I hope I'll alleviate that by the time I get to release this version. But the frame rates are pretty good. If I'm racing around in this without recording the video, I get up around 80 to 100 frames per second for the whole of the track. And you can see here it's pretty intense with the amount of trees that I've got running. Branches can overhang the track, makes for a good effect. And this track is around about 6 kilometers long, with about 2,500 trees. So I'll just shut up for a while and you can have a look at the effect. You'll notice the shadows are also popping in. They don't get rendered for the same distance that the objects do. Because they are a different object, they can be rendered at a different level of detail to the main object. And that also helps the frame rates. And now let's find a tree. Oh, missed. My driving's not that good. There we go. And I guess that's the end of the demonstration. But as you can see, the trees are nice. Hope you enjoyed this presentation.